You are a glutton for punishment. Yes, you are. All right. Let's take a look at this week. Hopefully you guys watched the lesson tutorial. We're dealing with rational functions this week. You're going to have to be able to figure out what the domain is, the vertical and horizontal asymptotes, and where the function has an x and y intercept. Now, in years past, I had kids graph these things out and all that kind of stuff, but this year I kind of figured, if we can figure out all of those things, we'll be good. All right, so rational functions, what we're going to focus on. A rational function is a quotient of a polynomial of polynomial functions. It can be written in the form, basically a polynomial function on top and polynomial function on bottom. And then we can find the domains and the ranges. And as I said, we're going to find the domain, the vertical asymptote, the horizontal asymptote, the x-intercept and y-intercept. Now, why do we find these? So it's easier to graph these functions. Now, I want to go through an example before we go on to the practice problems. The example that I'm going to give, I just made this up. Oops, I better turn my marker on so you guys can see it. If I give you something like y is equal to x plus 5 over x squared minus 25. Okay, what you have to be able to do tonight for the assessment, or this week for the assessment, is you have to be able to tell me what the domain is. You have to tell me what the vertical and horizontal asymptotes are. And you have to find the x and y intercepts. And the reason we do this is that at the very end, you should be able to graph a rational function. But that's, I'm not even getting to that this week. I just want you guys to be able to, find the domain, the vertical and horizontal asymptotes, and the x and y intercepts, okay? All right. And I'm going to walk you through how to find each of them. Then when we get into the practice, it should be fairly easy. Whenever I have a polynomial function on top and bottom, I try to reduce it down, okay? And here's why. X plus 5, and then the bottom factors to x plus 5, x minus 5. So this function, really, if you think about it, the x plus 5's cross out. This function and this function are exactly the same thing. Okay? Now, what happens because x plus 5 crosses off on top and bottom, something really special happens on the graph when x equals -5. And why do I say -5? Because that's what makes this equal to 0. At x equals -5, there's a hole in the graph. We don't even talk about that this week, I don't think. But that's what happens if you have a factor that crosses out on top and bottom. Then there's a hole at that. Whatever makes that equal to 0, there's a hole in the graph. No, it should be x equals -5 because it's whatever makes the factor equal to 0. And x plus 5, -5 makes that equal to 0. So at x equals -5, there will be a hole in that graph. All right. So now, all I have to do is look at this function to figure out what the domain is, what the vertical and horizontal asymptotes are, and the x and y intercepts. So how do I find domain? Domain is, when you deal with a rational function, domain is all real numbers except what makes the denominator equal to 0. So all real numbers except x equals 5. That is the domain. Now, a lot of people would say, but Mr. Shanklin, the domain is all real numbers except +5 and -5. And I would say, no, it's not. Because the x plus 5 on top and x plus 5 on the bottom cross off. That means that at -5, there's just a hole, but it's still a function at that point. Okay? So the domain here is all real numbers except x equals 5. Does that make sense, how to find domain? That is domain. Right, but you do have to say all real numbers except x equals 5. Okay, so the domain You can put any other number in here. You can put 20 in here, you can put 30 in here, you can put -5, you can put -30. You can put any number in here except 5, because once you put 5 in here, 5 minus 5 is 0. You can't divide by 0. That's why that is not part of my domain. So my domain is all real numbers except 5. Okay. How do we find vertical and horizontal asymptotes? Vertical asymptotes are very easy to find. Vertical asymptotes are any place that makes the denominator equal to 0. Okay? So vertical asymptote would be at x equals 5. The reason there's a hole at -5 is because it crossed off on top and bottom. That is where a hole is created. If you have a factor that's exactly the same on top and bottom and they cross off, there is a hole in the graph at that point. Whatever makes that equal to 0. So x plus 5, -5 makes that equal to 0. So there's a hole there. So in this problem, a vertical asymptote would be at x equals 5. So if I was going to graph this out, I would put a vertical asymptote at x equals 5. So 1, 2, 3, 4, 5. There would be a vertical asymptote. How do you find horizontal asymptotes? Well, if you watch the tutorial from this week, horizontal asymptotes are y is equal to, okay, they're horizontal asymptotes, and it is, and I always tell kids it's small over big is equal to y is equal to 0. If it's big over small, it's undefined. There is none. We would just put none. And if it's the same, and what am I saying? Big over small, small over big. It's the variables. What is the highest power on top and bottom? If the highest power on top and bottom, so if you take a look here, this is 1 here, this is 2. So it's a small over big. That means y is equal to 0 is a horizontal asymptote. So this function has a horizontal asymptote here. If it's big over small, so for example, if I had something like x to the third plus 4 over x squared, then there would be no horizontal asymptote. Now, if they're the same, so let's say it's x squared plus 4 over x squared minus 5, then you take the numbers in front of the variables, the highest power. So 1 over 1, so now my horizontal asymptote would be y is equal to 1. So that's how you find horizontal asymptotes. You look at the highest power on top and bottom. So this problem, the horizontal asymptote would be y is equal to 0. So then the last things we have to be able to do this week is find x and y intercepts. How do you find x and y intercepts? Usually what I do is I just go like this. In order to find an x-intercept, I put 0 in for y. If I want to find the y-intercept, I put x in for 0 and solve. So if I put 0 in for x, I end up with, if I put 0 here, I end up with 1 over -5. And now if I solve it, so y is equal to 0, then you solve it, you cross multiply here, and you'd end up with 0. 1 is equal, so you just end up with 0, okay? So it doesn't have, or 1 equals 0, so it doesn't have a y or an x-intercept. Okay, it never crosses the x-axis. And doesn't that make sense? And you have a hypotenuse there. So my graph, so there is none. So my graph is going to look like this if I graph this thing out. That is what that, but you don't have to graph it out tonight. Oh, I'm wrong here, because at -5, there will be a hole here, okay? It'll still continue on forever, but at -5, there's a hole in that graph because we cross it out on top and bottom. So that is everything that you have to be able to do this week. You have to find the domain. You have to be able to figure out what the vertical and horizontal asymptotes are and what the x and y intercepts are, okay? Now, I did have a Desmos presentation, but since there's only 2 of you here, we'll just work each problem out on the board. Here's the, if you did want to go into the Desmos presentation and work it out, let me give you the link to that. If you want to go in there and work those problems out, here's the link to it. Okay. There's only two. Like in my algebra class, there's like 60 some kids that come to class, so we work through the problems together. So they're working it out at the same time. Okay, so in this problem it says find the x and y intercepts of the rational function. Okay, so you have in this practice this week you have to be very careful and just figure out what they're asking for. This one it asks for x and y intercepts. Okay, so if I'm looking for x and y intercepts, okay, if I want to find my y-intercept, I put 0 in for x. If I want to find my x-intercept, I put 0 in for y. Okay, so this one's the easiest. You just put 0 in here. So that gives, what am I left with? I'm left with -6/3 or -2. Okay, so if I was going to graph this thing out at 0, -2, that is my x-intercept. What's my y-intercept? Well, in order to find a y-intercept, usually I just set it equal to 0 and then just cross multiply. So I'm just cross multiplying here. So x plus 3 times 0, that's just 0. X minus 6 times 1, that's x minus 6. If I add 6 to both sides, I end up with x equals 6. So my y-intercept, or I'm sorry, this would be my, so 6, 0. Ah, boy, I messed that up. That should have been 0, -2. It's a y-intercept. And this is my x-intercept, so 6, 0 would be way over here. So if I look down here, x-intercept at 6, 0 and y-intercept at 0, -2, that looks about right. Okay, any questions on finding the x and y intercepts? Sorry about that. Okay, any questions on x and y intercepts? You guys okay with that? All right. Problem number 2 on this week's practice. It says find the x and y intercepts of the rational function. So I'm going to let you guys do this one. Okay. What is your x-intercept? What is your y-intercept? Okay. And then I'll let you guys have a couple minutes to do it. Again, you can do it in Desmos if you wanted to. Doesn't matter, but you don't have to. You can just do it in the paper and pencil and just give me the answer. All right. Any answers? The first one, when you put the x equals 0 in, so finding the y-intercept should be fairly easy. Okay, what's the y-intercept? Zero, 4. I would agree with that, because if we put 0 in here, if we put 0 in, we end up with 0 plus 64. over 0 plus 16. 64 over 16 is 4. So when the x value is 0, the y value is 4. So my x-intercept, 0, 4, I'm sorry, my y-intercept is 0, 4. Okay? Then the y, or the x-intercept, a little bit tougher to do. I mean, you have to, I always just do it as cross multiplying. So I end up with x squared plus 16 here is equal to 0 over 1. If I cross multiply going this way, I end up with x to the third plus 64 is equal to 0 times x squared plus 16, which is just 0. I'm going to bring the 64 over here, so x to the third is equal to negative 64. So now if I take the third root of both sides, and you can take the third root of both sides, is that 4? But it's going to be plus or minus 4, isn't it? Is it going to be positive 4? I don't think it'll be positive 4, just negative 4, right? Because positive 4 times positive 4 times positive 4 would not be negative 64. So just negative 4. So negative 4, 0. So letter B, x-intercept negative 4, 0, y-intercept 0, 4. I like it. Okay. Next question. This time it asks us to find the vertical asymptote. Okay, vertical asymptote. That one should be fairly easy. Vertical asymptote is what makes the denominator equal to 0. So what is my vertical asymptote? And remember, vertical asymptote is always x equals. A horizontal asymptote is always y is equal to. Okay, so this one should be x equals 8, because that's what makes the denominator equal to 0. So letter B is correct. All right. Vertical asymptotes, fairly easy to find. Determine the horizontal asymptote of the function. Okay. Now this one's a little bit tougher. So in this problem, you take a look at the highest power on top and bottom. I have the highest power on top is 2, the highest power on bottom is 1. So I've got a big over a small. That means there is no horizontal asymptote. None. Okay? Because that's going to be a huge number. It's no horizontal asymptote. Now, let's say it was the opposite way around. Let's say it was x minus 2 over x squared plus 1. Well, now I have a small over a big. Small over big means y is equal to 0. You'd have a horizontal asymptote at 0. Okay, does that make sense? How you find horizontal asymptotes. Okay, because a lot of kids really struggle with horizontal asymptotes, and they're fairly easy to find. All right, next question. Which of the following functions has no horizontal asymptote? Okay, so which one has no horizontal asymptote? Letter B. Yep, I've got a big over a small. It's absolutely correct. Big over small. Boom. Letter B has no horizontal asymptote. Very good. This one's a little hard to read, but it says, find the intercepts and asymptotes. Okay, so now we have to find both things. We have to find the x-intercept, the y-intercept. We have to find the horizontal asymptote and the vertical asymptote. Whew. Okay. So the first thing I do is I always start with easy. I always find y-intercept. That's always easy. So I'm going to put 0 in for x. If I put 0 in here, I get 32 over 4, which is what, 8? So I got 0, 8. That's my y-intercept, right? Okay, then to find my vertical asymptote, okay, now this one's a little bit tricky because can we factor the top and bottom? And that's the first thing I would do if I could. So I'm going to take an 8 out of the top. So that gives me x plus 4 here. I'm going to take a negative 4 out of the bottom. So that gives me an x minus 1. Nothing crosses off. So I really don't have to worry about anything crossing off. It just makes finding the vertical asymptote a little bit easier. The vertical asymptote is going to be x equals 1, right? Whatever makes the denominator equal to 0. So vertical asymptote, x equals 1. Now the horizontal asymptote, the powers on top and bottom are exactly the same. So if the powers on top and bottom are exactly the same, then you just take the coefficients in front. So that would be 8 over -4, which is -2. So my horizontal asymptote is y is equal to -2. And then the last thing we have to do is we have to find the x-intercept, right? All right, so I said it equals 0. If I cross multiply, that gives me 0. So I have 8x plus 32 is equal to 0. Bring that -32 over, so divide by 8, so that's going to be -4, 0. Is that right? So somebody said letter A, x-intercept. I'm not going to y-intercept. Did I do this wrong? X-intercept, y-intercept. Okay, horizontal asymptote, y is equal. I'm going to go with letter B, okay? Because 0, 8 is a y-intercept. So I'm going to go with letter B. When in doubt, go with letter B. All right, so does that make sense? How I came up with the x-intercept, the y-intercept, the horizontal asymptote, and the vertical asymptote. Is that okay? You guys okay with that? I don't want to go on if there's something that you guys don't understand there. Okay. All right. Let's try the next one. The next couple I'm going to let you guys work on and see if you get them right. Okay, so the next problem is very similar. Okay. It asks for the y-intercept, the horizontal asymptote, and the vertical asymptote. I think they would ask for the x-intercept, but I don't think there is one. So I'm going to let you guys work on this, see what you get for an answer. Letter B. Okay, so if I was going to do this problem, first thing I'd do is I always do intercepts, put x 0 in for x. So that gives me -3 squared. -3 squared is 9. 72 over 9 is 8, isn't it? So it looks like my y-intercept is 0, 8. Doesn't look like there's an x-intercept. So now I'm going to find. Now, this one, the vertical asymptote, whatever makes the denominator equal 0. So x equals 3 should be a vertical asymptote. A horizontal asymptote, which is y is equal to, the highest power on the bottom is x squared. There's no, so this is a small over a big. So small over big is y is equal to 0. So I've got y is equal to 0, 0, 8, x equals 8. I agree with you guys 100%. The answer should be letter B. All right. What is the domain of this function? Be careful. Be careful on this one. Okay. Well, yeah. Be careful. I'm hoping I corrected this one. Okay. I would factor first before you do anything, because remember, if it crosses out on top and bottom, there's a hole in it. Doesn't mean it's not defined. letter B. All right. If I was going to do this problem, I'd factor. Top becomes x plus 5. Bottom becomes x minus 5. I'm sorry, top becomes x plus 5, x minus 5. If I factor the bottom, is that x plus 5 and then x minus 1? I think that's right. So the x plus 5's cross off. That means there's a hole. There's a hole in the graph at x equals negative 5, but they're not asking us about that. But where is the domain is going to be all real numbers except x equals 1. Uh-oh. Oh, I forgot to change this. It is 1 on the practice. I had to go in there and get rid of that negative sign in there because it should be x equals 1, right? It should be all real numbers except x equals 1, which is B, but I forgot to change it on this one. It is x equals 1, and on the practice I did go back and I changed it because it's like, man, they don't have the right answer on here. I think they wanted people to say letter C, but that's not correct because that crosses off. And if it crosses off, it's not part of the domain. So it's just a hole in the graph. All right. What is a horizontal? I know this isn't the question, but what is the horizontal asymptote here? You guys know what the horizontal asymptote is on this problem? What is the horizontal asymptote? Y is equal to 1. That is absolutely correct. Very good. And the reason is the asymptote, or the x values, they're the same. X squared is the highest power, so you just take the numbers in front, which is 1 over 1. Very nice. So finding horizontal asymptotes are pretty easy when you understand what you're doing. Okay, determine the zeros, if any, of the rational functions. Okay, well, what are zeros? Zeros are when you set the function equal. It's the x-intercepts, right? So if I was going to solve this, I would just put this as 0, cross multiply, you end up with x minus 4 times 0 is 0, and then x squared minus 49, so I end up with x squared minus 49 is equal to 1. Oh, I'm sorry, it does not equal 1. I'm just cross multiplying, so it equals 0. And then I bring the 49 over, so x squared equals 49. So x equals, what is it, plus or minus 7? Because when you take the square root, you have to use positive or negative. So positive or negative 7. And realistically, you could just graph it and find out where it crosses x-axis. I mean, that would also work, right? It's another way of doing it. Which of the functions has no vertical asymptotes? No vertical asymptotes. This one's a little tricky. But which one would not have any horizontal asymptotes? I'm sorry, vertical asymptotes, not horizontal. Which one would? Letter D. Letter D, if you factor this, what do you get? X minus 5, x minus 4? Is that right? Did I factor that right? And then I have x minus 5, x minus 4. They cross off. What is this function really? This function really is, so it really is y is equal to 1. That's, if I graph this out, you end up with y is equal to 1. You'd end up with a graph that looks like this. That's it. Well, I take that back. I take that back. Okay, so if you really understand this, what would my graph really look like? I'm close. There would be holes. There would be holes at 4 and 5. There would be a hole here, and there would be a hole here. That's exactly right. So there is no vertical asymptotes there. There's going to be a hole, though, at 5 and 4. So this is the type of problem that I would put on an exam. It's like I'd give this problem and I say graph it, and most students would say, I don't know how to graph that thing. What are you talking about? You don't know how to graph a horizontal line? with two holes in it? Because that's basically all it is. That is the whole function graphed out. So it's like sometimes they look really difficult, but in reality, it's just a horizontal line at one with two holes in it. So sometimes the graph looks really difficult, but in reality, not so much. That was the last practice problem. That is it for this week, guys. Any question? If not, have a great week, and hopefully we'll see you back next week. Same time, same place. All right. Bye.